What's up, guys? So today I will want to show you some capabilities of STAAD.Pro regarding its API or the application programming interface. This is for those who are interested in doing some programming and coding. But first off, let me add a disclaimer that I am in no way connected with Bentley or any companies that's uh, a vendor for STAAD.Pro. So I have here, I opened an example spreadsheet, which I did. By the way, you can connect your STAAD.Pro through the OpenSTAAD with almost any type of programming language, but for my purposes, I think Microsoft Excel spreadsheets are useful for my calculations and other documents that I'm preparing. And also, Microsoft Excel has the Visual Basic for Applications or VBA, in which you can also connect STAAD.Pro from there. And then here is an example model which I was working on. What I'd like to show you is that I made some tables in here which can extract the output forces or envelopes from the model. That is only possible if you have a model that's already had an analysis on it. So notice I have run, copy and print, and then extract moments, insertion moments. I'll go to them later on in the video. But first off, let me try to start with this forces summary. This is nothing but similar to the organic output of STAAD.Pro. You see here, for example, I have the 102 combination, dead and live load. Then it's just equivalent to this table in here. Notice these values. But take note, these values are from the entire model, meaning this is the envelope of forces given all the members. And this would change if we would specifically choose a member right here. So just for an example, let's just take this beam 308. Okay, beam 308. Oops, sorry. Beam 308. Okay, when I click the summary of that, all I can get are the results from the specific combination and specific beam. Notice it's not much useful if we're going to design this member, so I will display all the possible combinations on this set. For this case, I'm using an American ASD combination, so you see there. Okay, now we can compare. Let me do that again. Okay. So based on beam 308, we can compare from those combinations the possible values of our forces or an equivalent of an envelope. So I will try to mimic this table using the spreadsheet that I did, this one. But I think I have to use this in terms of grouping. Let me just see, yeah, in terms of grouping. So for me to be able to use that, I need to see the groups I have in here. For example, I have the second floor. I'll just isolate it in a moment. Okay. So I have the second floor, meaning if I run this script, I would extract the forces based on that group and from the applicable load combinations. For example, we selected 2F or the second floor. And then from here, we would need to select the applicable combination. So remember that we picked 101 to 106. So from here, we also use the same. So we just have to wait for quite a bit. I cannot exactly recall, but I think I still have some flaws on the algorithm that I tend to miss some values on the envelope, and those things are I'm looking at to be improved upon. And also notice for the formatting, I already emboldened this diagonal line to demonstrate the min-max of every force category. Okay, I think it's done. So I'll go back to the model and then compare the results. Remember we chose 101 to 106, and for the range we have to select the group 2F. Now we go to the summary. They have to be at least within the same range, or ideally the same. So notice for the actual forces we have 131.06 and negative 129.62. Yeah, so we got those values. And for the minimum and maximum Fy, 242 and negative 257. Yep, we also got those values. And then the Fz, 297, negative 282. Yep. And then so on for the MZ, 776, negative 668. Okay, cool. We got those values. Now, you might be questioning why I need to go through this, this entire table thing when I already have them in this STAAD interface. Well, for one thing, I just had good time. I enjoyed coding this one. But also for the thing, I have this button here that could simply print it out. I could easily print them within a second. Whereas if I go to the STAAD interface, it might take me a lot just to compile the reports. It's more on a documentation thing. Okay, so for the extract moments, the difference between section moments and extract end moments is that I use a different algorithm for the section moments. That means for section moments, I divided each beam or member for I think around 4 to 5 subdivisions, and then I would go to extract the moments, major moments within those 5 sections. Whereas if we use the extract end moment, this script would simply extract the end moments, the start and end moments of the member. Now, the thing about that is you won't be able to capture any intermediate value. For example, the maximum middle moment, or whether a larger bending moment would occur somewhere within the middle portion of the member. So let me demonstrate that to you. For that case, we don't need to select groupings. We just have to pick specific member or members. For example, again, I'll go back to this one, member 208. So all I have to do is just select it and leave it at that. Then go back to the script, and then I just have to click this section moment. But first, let me clear this up for you. Okay. So if I press section moments, expect that we would get the envelope from ends and within several sections within the member. Let's just I'll just choose 102. Okay, so member 208, length 5.29, the maximum moment is 53.31. Now, notice that you have here the 102. That means that's the applicable combination. So going back to check within STAAD, let's just double click here, shear and bending. Major moment is Z, by the way, and then 102. So you see 53.31. So that's 53.31. Now, It just so happened that the bending moments, the maximum bending moment, occurred at the starting joint. Now, the case might be that the maximum bending moment might occur somewhere here in the middle. For example, we have a simple beam in here. As you see the results at the end, I'll just pick this one and then again 102. Yep, so you see 5.4, member 201, moment 30.41. Definitely you cannot get large values within the ends because they are released. So expectedly you have 0 or maybe very small amount. So again, shear and bending 102. So you see the maximum moment occurred within exactly the middle because it's simple beam and uniformly loaded. So 30.41. So that's the difference. For example, if I use extracted moments, expect that we would get 0 or maybe even a very small amount. Again, 102. See that? Just as I told you earlier. So again, this one, we'll be able to get the 30.41. So that's it. Now, you can somehow use this and then extract the applicable section, and it has these values based on 0.66 of FYSX. This is helpful if you're going to run for initial sizes of your sections for preliminary design purposes. Okay, and then I have another one in here for the columns. I use the columns for the forces envelope. I'm going to extract the maximum axial force, maximum MY and MZ, and then the corresponding values of each forces. For example, again, I will clear this out. I'll just clear this out. Then let's pick a random. For example, this. Okay, this column. Beam 1010. And again, I just need to pick this one. We can try to use several combinations. I mean, the script would still choose whichever is larger. So let's use the 101 to 106. So we have this value. So going back, beam 1010. So let's see here if that matches. Beam 1000. And the load range, yep, correct. Okay. And then once we click the summary, we'll notice that the maximum Fx or axial force is 1251.2, exactly that. The corresponding moments My, Mz 0, 0. And then maximum Mz 288.88, corresponding My 2.7, corresponding axial force 997.65, and for My 136.92, corresponding Mz 682, and then the corresponding PS 738. So that's it. If you have some comments on how to improve on this, or you have some ideas on how to work around or to improve this script, or if you like it, just place your comments below or place a thumbs up on this video. So thanks for watching.